College Algebra, Chapter 13, our last three sections, 13.1, 13.2, 13.3. This is 13.1, sequences. What is a sequence? It is a function whose domain is the set of positive integers. What are the positive integers? The natural numbers. Now, really, when you get into upper level mathematics, you can use any integer that you like, so you can have negative numbers, but for us, be positive integers. That's the 1, 2, 3 counting numbers. So if the domain is that, then these functions, so if f of x is 1 over x, then you can get a sequence of integers. Plug that in. What is f of 1? It's 1. What is f of 2? It's 1/2. What is f of 3? It's 1/3. f of 4? 1/4, etc., etc., etc. Now, for mathematicians, it gets a little, I guess, irritating to always do f of 1, f of 2, f of 3, because this is always going to be the same, a function with 1, 2, 3, 4, 5. So we're going to talk about these terms, and we're going to use a sub n, subscripts, instead of the parentheses. So our a sub n is 1 over n. This is the general term. And you keep putting in 1s and 2s and 3s and 4s for the n. They use n instead of x in these situations. And you'll get the list. So a sub 1 is 1 over 1, which is 1. The same as 1 over x. A sub 2 is 1/2. A sub 3 is 1/3, etc., etc., etc. So we can write this several different ways. If you'd like, you can write this as with these braces, and that signifies to a mathematician with an a sub n in between, it's a set of answers whose the domain is integers because of this a sub n notation. You'd have to know what a sub n equals. You could then say this is 1 over n, because that's what a sub n is. A sub n could be anything. The idea is you're going to have some sort of equation, and when you plug in integers, you're going to get a list, a sequence of numbers. Now we can write these as a sub 1 equals a sub 2 equals, but normally we just write them with commas in between. 1, 1/2, 1/3, 1/4, ... And so this is one way to write our sequence. So a mathematician who is pretty much lazy all the time, instead of this a sub 1, now we can talk about this. This is a sub 1, this is a sub 2, a sub 3, but you don't have to. You can even put in the a sub n as your general one and put some more dots to say this thing goes on forever. So we want in mathematics to determine a pattern, usually. So let's see if we can come up with a pattern for a couple of things. How about if I give you 1 over 1 times 2, and then 1 over 2 times 3, and then 1 over 3 times 4, and 1 over 4 times 5, can you see a pattern to give me the general term? Remember, this is a sub 1, a sub 2, a sub 3, a sub 4. You can use different letters. You can use A, you can use B. Lowercase, though, is what you should use. So if you look at this, you say, well, if this is a sub 1, notice the numerator is always 1. So you can write that as a 1 no matter what. It's the denominator that keeps changing. Now the left number is the same as that subscript, which is just n. And the right number is the subscript plus 1. So you can write this as n plus 1. So this is 1 over n times n plus 1. And you can multiply that out. I guess 1 over n squared plus n. If you want to write it as a sequence, you can use the braces. You can write out the list of numbers. This would be 1 over 2. This is 1 over 6. 1 over 12. 1 over 20. And what's interesting is when we write it this way, it's a lot easier to see what's going on than looking at this. Here we'd have to figure out that pattern by looking at a bunch of different things. So let's figure out a pattern. Let me change colors. How about a pattern that would be 2, -4, 6, -8, 10, ... So now we got to go through sort of a process here. Remember here, if we would have gone backwards, we said the numerator is always 1, and let's, you can use addition, you can use multiplication. Many times multiplication is better, but it could be just addition. This, we're adding 2, adding 2, adding 2, adding 2, adding 2, adding 2. So really, if this is my a sub 1, it's really if you want to, you can look at this several different ways, I guess. This is the first term. This is a sub 1. And you're going to use that 1 somehow. You got to use that in there so you can use the a sub n somehow in your general description, right? So you got to use the 1 in here somehow. So this is 1 times 2. Now a -4 is a -2 times 2. Now why didn't I write it as 1 times 4? Because I want to get the 1, 2, 3, 4 involved here too. A sub 3, I should have done this positive, negative, well, doesn't really matter. This is 2 times 3. And the -8, let's do one more, is -2 times 4. So I'm getting a 1, a 2, a 3, and a 4. So that means my a sub n needs an n in here. Then I'm getting a 2, a -2, a 2, a -2. So I've always got a 2, so I'm going to multiply by 2. But now I've got to change signs every other one. Let's see. And the way to do that is with a -1. Now, if you take -1 to an odd power, you'll get a negative number. If you take -1 to an even power, you get a positive number. I want my odds, 1 and 3, and I guess the next one would be 5, to be positive. So I can't use the n up here because this would be a -1 to the first, which would make this negative, and I don't want a negative. So I'm going to add 1, which will make it positive. So does this make sense? A little bit? You take care, you make sure you get the n involved somehow. 1, 2, 3, 4. Then this has always got a 2 for the other stuff. I should put a double line underneath it. And then it goes plus, minus, plus, minus. And all of those ideas for a bunch of these examples is when you would use these ideas here. If you needed to switch sign, plus, minus, you got to use that -1 to some power. Make sure you get the power the right order, so to speak. So this then becomes, you can do the -1 to the n plus 1 usually first, times 2n. And that is your a sub n. Does this make sense? Do you guys know what factorial is? Let's get that in here. Factorial. 5 factorial is 5 times 4 times 3 times 2 times 1, or 120. N factorial is n times n minus 1, n minus 1, times n minus 2, times n minus 3, times until you get down to 2 times 1. I guess that 1 doesn't really make any difference. You count down and multiply as you count down. That's what factorial is. That's what the exclamation point is. Okay.